Here we're going to solve the system using a matrix inverse and multiplication. Our first step is to find the matrix inverse, namely of the coefficients. So looking at the coefficients, we have three variables, three equations, so that means we need to pair it with the 3 by 3 identity matrix. There's a bunch of ways we can get a 1 in the 1, 1 position. We could, for instance, swap row 1 and 3 and negate the first row. We can add row 3 to row 1. We could multiply the first row by a half. Any of those are fine. Again, we're going to use our calculator. So the calculator will handle all of the heavy lifting, especially with fractions. So we shouldn't fear fractions at this point. I'm going to add the third row to the first row. Now, assuming there's a 1 in the top position there, with the 1, 1 position, we can say negative 3 row 1 plus row 2 makes row 2, and negative row 1 plus row, I'm sorry, not negative row 1 because it's already a positive 1. Oh, I erased too much. Make that eraser smaller. All right, let me make that. So we could just say row 3 plus, nope, row, see, I did it again. Row 1 plus row 3 makes row 3. All right. Same deal as in the previous video. Pause it, do those three operations, and then we'll check answers. So there is the result, the bottom there. Comment, you may have noticed that I made a typo or a right-o. I had actually written 1, 0 instead of 0, 1 for the last two entries there. So make sure that was fixed before you did these operations. Otherwise, you won't get the same answer. So just FYI. All right, rewriting this new matrix in. If you got done already, then think about the operations. To clear out the second column. You can go head first, and you can multiply the second row by negative 1/3 to turn that 2, 2 entry into a 1. Or you could swap the second and third rows to put a 1 in the 2, 2 entry. That's fine as well. I think I'm going to do that. I'm going to swap the rows. So row 2, double arrow row 3. And then assuming there's a 1 in the 2, 2 position, I can say negative 2 row 2 plus row 1 makes row 1. And remember now there's a negative 3 in the 3, 2 position, so 3 row 2 plus row 3 makes row 3. As before, do those three operations. Let's come back and make sure you get the same thing. Okay, so we should have those values you see in the calculator screen. Oh, that should be a 0. As a comment, I'm giving you different options on how to perform Gauss-Jordan here. Just like with systems of equations, just because you want a different route does not mean you'll get a final different answer. The intermediate steps will be different, but the final answer will be the same. We only have one more operation to go, and it's to turn that 1 into a 0. So we'll use the third row by negating it. We'll add it to the first row, and that makes the new third row. Again, you could just do this in your head if you want to. Just be careful. And he copies down the stuff that does not change. If you don't feel like doing your head, that's fine. Use the calculator. or an abacus, your choice. Excellent. So we just found that inverse. Awesome. You go over there. That's not your new home. But to finish off this problem, in order to solve the system, we will take that inverse and multiply it by the constants. 5, 8, -1. We have a 3 by 3 times a 3 by 1. Since the number of columns of the first match up to the number of rows of the second, then the result will be, in this case, a 3 by 1. By design, the first one will be whatever x is, the second one will be whatever y is, and the last one will be whatever z is. So if you want to, you can put this into your calculator and multiply. Or you can do it by hand. Again, multiply corresponding entries and add. Doing so, you get -7 for x, 3 for y, 5 for z, and check out the matrix multiplication video if you forgot how to multiply matrices.